last one of the parabola basics that we're doing. Let's orient ourselves. The sketch below shows the graphs of f of x, which is a side-face parabola, and g of x, which is a straight line, but they don't tell us anything about it. The graph of x has x-intercepts at a and b, where b is 1 and 0. Let's add that in. And a turning point at c. Turning point. A straight line passing through A and C cuts the x-axis at E. Write down the coordinates of the y-intercept of F. Okay, so for 4.1, you can straight up look at your thing and you can remember that this is ax squared plus bx plus c. We're in that format, so this guy is my y-intercept. So we can straight up just say 0 and 3. So let's add that in. That's R3, or you can go and calculate it and say, okay, so f of x equals negative, but substitute x was 0, not plus 2, 2 times 0 plus 3, and then we end up with y equals 3. Boom, 0 and 3. Booshk, donezo. Show that the coordinates of C are -1 and 4. So you have two options here. You can use, for the grade 11s who might be watching this, what you can do is you can say x equals negative b over 2a. I'm going to say, okay, my b of minus. Now remember, the b has its own minus, so please don't just leave it out. And 2 times a being -1. So negative times a negative gives me a positive, and then I have one extra negative, so that's going to be a minus, and then we have 2 divided by 2 is 1. Okay. Okay, -1, and then I'm going to substitute that into my equation to find the y coordinate of my turning point. F of -1 equals -1 squared minus 2 times -1 plus 3. This will become a +1, but there's a negative, so that's a 1. -1 plus 2 plus 3. 5 minus 1 is 4. Therefore, our turning point is -1. And now for the matrix, if you wanted to flex a little bit, you could have said, I'm going to find the first derivative equals -2x minus 2, and I'm going to set it equal to 0. Minus 2x 2, the 2 goes over, I have 2 equals -2x, divide by -2, divide by -2, x equals -1. And then I would substitute this answer right into there, and I would get -1 and 4. Because maybe you forgot this equation, or maybe you just moved on with your life and you're like, I am beyond this. I am better than this equation, which you're totally allowed to be. All right, write down the coordinate. Oh, wait. We just showed this was -1 and 4. Great. Write down the coordinates of A. You have two options here. I'm going to show you the short one and I'll show you the long one. So for 4.3, you can say this is this line where x equals -1 is the axis of symmetry for the parabola, which means this distance equals that distance. So to go from -1 to 1, I went 1, 2. That means I'm going 1, 2 backwards. So if this is -1, this would be -2, and this would be -3. So I would straight up just say -3 and 0 for A. But let's say you're stressed and you forgot about this. So then what you need to do is you're just going to say, hey, A is an x coordinate of this parabola. So I'm going to say f of x equals minus x squared minus 2x plus 3 equals 0. Okay, and now I'm going to factorize. I don't like these minuses, so I'm going to divide everything by minus 1. Divide by minus 1, divide by minus 1. So I end up with a positive x squared plus 2x minus 3. 0 divided by anything is 0. This is implacable. X factorize, you can use the formula, you can use your calculator. It's going to be positive 3, x minus 1. So I end up with x equals negative 3 or x equals 1. Woo! Hang on, the sun is up. I just want to open up the curtains. You have to let beauty into your life. The beauty levels in my life has just increased. Where were we? So we have negative 3 and negative 1. So we say A is negative 3 and 0. Okay, doesn't matter which one you do. Both get you to the same answer. And, you know, sometimes while you're writing, you just don't remember. And it is what it is. Okay, calculate the length of CE. And for 6 marks. Okay, so it looks like a lot and there might be a little bit of panic, but hey, actually this one is going to be super doable. Way more doable than you realize. I have scribbled so much over here. There we go. So there's my C. I know this coordinate is 1 and 4, or negative 1 and 4, but I don't know what this coordinate is. And I see that E is on my straight line. Okay, hang on. Let's just pause for a moment. So sometimes, how do I want to say this? Sometimes a question comes at you and it's a bit twisty. And this is not about memorizing the steps for this question because it's, I mean, it's a lot of memorizing. What I want you to listen to is how I get myself there, how I think about the problem, how I break it down into smaller steps. So I look at C and E and they ask me for the length. I see this is not a vertical, it's not like a vertical or a horizontal line, so I can't use any of my usual tricks. It's a diagonal line, so I'm going to have to use the distance formula. So I want to use distance formula. But then I'm like, I have coordinates here and I don't have coordinates over here. Which means is I want coordinates for E. Do you see? I'm kind of like, I go to the place where I want to end up. And then it's like, but I don't have E. So I want the coordinates for E. In order to get the coordinates for E, E is the y-intercept of my straight line. So I want my straight line, want the equation equation for g of x. And so now what I'm going to do is knock those off one by one. I'm going to say, okay, can I find the equation of the straight line? It's like, hey, I've got a coordinate over here, got a coordinate over there. Yes, I sure can. So I'm going to say my straight line, g of x, I have g of x equals mx plus q. I'm going to get my m by saying y over x1 minus x2. Ugh, what am I doing? y2 minus x2. Over here, my y is 4. My x is minus 1. Minus. Over here, my y is 0. And below the line, it's negative 3. So we have 4. Minus 3 plus minus 1 plus 3 gives me 2. Positive 2. So my gradient is 2. Okay, and then I want to find one more. I have y equals 2x plus q. So I'm going to substitute in any one of my coordinates. I'm going to go with that one. X is 2 and negative 3. Y is 0 plus q. I end up with a negative 6q. Take it over to the other side. Q is 6. And does that make sense? It sure does, because I have a positive gradient and I have a rather high y-intercept. Okay, so I have the equation for g of x. Now I want the coordinates for e. Now I can straight up just say e is 0 and 6, or you can go and calculate it using your newly found equation, 2x plus 6 equals 0 plus 6. So y equals 6. All right, you could have done that. I am running out of space over here. So I wanted the coordinates for E, and now I want to use the distance formula. No, correction. I want to use the distance formula. The problem is I don't have enough space because the distance formula is a lot of writing. But I'm going to erase this. And distance formula. CE equals. I like to put a square here because then I don't have to draw that awkward long thingy, but you don't have to. So we have xc minus xe squared plus yc minus ye squared. And then I'm going to say x of c is minus 1 minus the x of e, which was, this was 0 and 6, so that would be 0. Bracket close, squared, plus y of c is 4 minus y of e is 6 squared. This leads to 1. 4 minus 6 is 2. 2 squared is 5. 2 squared is 4 plus 4 equals 5. And then remember we had CE squared, so CE equals square root 5. I have my dots. I don't believe you. No, I don't believe. Yay! There we go. Boom. So far, so winning. 4.5. Determine the value of k if h of x equals 2x plus k is a tangent to the graph of f. All right. Now, I want to remind you that we just, 4.5, we've just found out that g of x equals 2x plus 6. So if they say h of x equals to 2x plus k, this is a straight line because this is kind of in the formula mx plus c, except we have a k instead of a c and our m is 2. And the other thing that we know is this line had a gradient of 2 and this line has a gradient of 2. So somewhere over, somewhere over here, there is a line that's running parallel to this one, and it's a tangent. It only touches the parabola. Okay, so this is for 5 marks. I should have said this in the beginning. Grade 11s, this question is not for you. Also, 4.6 is not for you. And 4.7 you can't do either. All right, so also grade 12s, you won't be able to do this yet if you haven't done differential calculus. Looking at the value of k for h of x equals this. So what we want to do is we want to find that coordinate over there. I've already scribbled so many times. We are looking for the exact coordinate over there. We want the coordinate on the parabola when the parabola's gradient equals 2. That is our link. So we're going to take the first derivative of f of x. So we're going to derive that. So we have 2 times -1 gives me -2x minus 2. And I'm going to say, usually we set it equal to 0 because we want the turning point. But because we're not at the turning point, the gradient's going to be equal to 2. 2x minus 2. The 2 goes over. It becomes a positive. 4 equals -2x divided by -2 is -2 equals x. So at that point, the coordinate is -2. We want a y coordinate. Y equals into the original equation. So we have original equation, substitute in -2 minus -2 squared minus 2 times -2 plus 3. Okay, so -2 times, this would be, sorry, my brain just went oink. The -2 times -2 is 4 times the positive 4 times a negative gives me a -4 plus 2 times 2 is 4 plus 3. These two like die. Therefore, the y value is 3. So we have 3 and 2 over there. Okay, and now we just have to solve for k. So we have h of x is all of this business. So we have y equals 2x plus k. Substitute in my coordinates. So -2 and 3. That would be a 3. 2 times -2 plus k. This becomes -4. Okay, plus k. 4 goes over. 7. K equals 7. There you go. Answer. And that kind of makes sense because we want this line here to be a little higher up, a little elevated compared to this one. So if this was 7, that would make sense, more or less. Okay. Guys, by the way, I just want to remind you, if something doesn't make sense, you are welcome to pop a question in the comment section. And then I'll know to explain something in a different way next time. Determine the equation of the inverse of g of x in the form whatever. Okay, so we had g of x equals 2x plus 6. We found that earlier. We've already done that work. So we have y equals 2x plus 6. And to find the inverse, we just swap these two. We have x equals 2y plus 6. Now we solve for y. So the x minus 6 equals 2y. We divide by 2, divide by 2, divide by 2. I end up with y equals, this you can leave as x over 2, or I like to write it as this. Remember, x over 2 is the same as a half of x, or because 1 over 2 times x over 1 would just give us x over 2 again, and this guy is on an invisible one. Okay. Where were we? So we did this one. -6 divided by 2 is -3. So you can leave it like this or just tidy it up a little. -3. Easy peasy, lemon squeezy. Nothing weird there. And then they say, for which values of x is g of x bigger than g naught, the inverse of x. So if the inverse of x equals a half x minus 3. First, what I do is just orient myself. I have my two equations, and I am struggling to see in my mind's eye, to imagine what this graph is going to look like. So I'm just going to do a little bit of a very rough sketch. So there's a 3, that's going to be -3. That's the y-intercept, right? And then it's going to be a positive gradient, but quite a gentle gradient. So something like that. There it goes. So over here somewhere is an intercept. And at that point where they intercept, g of x will be bigger going in that direction. So I just have to find their intercept, basically. So let's do that. It's where the two graphs are equal to each other, because when the graphs intercept, they are equal. And there's 3. I'm going to take the 6 over to the other side. So I have negative 9. That one, I have 2x minus a half x. So I end up with 1.5 x, which is the same as 3 over 2x. What you can do is for those of you who want to be on a calculator, you can say this becomes 1.5x equals -9. And then you divide by 1.5, divide by 1.5. For those of you who are a little more comfortable with fractions, this becomes -9 times the reciprocal, 2 over 3, douche, 3 times x is equal to -6 minus 6. There we go. Okay, so we know somewhere over here where x equals -6, the two lines intercept. And from that point going forward, the graphs are, our original equation is bigger than its inverse. So we would write x needs to be bigger or equal to -6. Or you could have written -6 is smaller or equal to x. Or you could have written x is an element of -6 included, and it continues for infinity. To infinity and beyond. Man, that was a cute little movie. Anyway, there you go. That is it for today.